Hello YouTube, welcome to my channel. In today's video on circuit analysis part 2, we're going to look at the concept of resistance, conductance with some practical illustration. Don't forget to give me a thumb up if you like the video. And more importantly, don't forget to subscribe so you won't miss out our videos. So let's get started. I want you to imagine what the world would have been like without control, without obstruction, without resistance. If things were allowed to continue moving without stopping, if the sun were allowed to keep shining without stopping, we would have been in a world of chaos, and no one would have appreciated their worth. But with resistance, not only are we in charge of these natural resources, we tend to be able to channel them to locations where they produce and yield their maximum abilities. Let's take example the river flow. We could just sit and watch the river flows countless number of times without making anything out of it. But by building dams and reservoirs, we conserve this awesome energy and utilize it in electricity production. And that is one of the benefits of resistance. Resistance is simply a concept used to describe the hindrance or opposition to movement of something. There are various interpretations of resistance, but for the sake of this video, we are going to center on the resistance of a resistor, as this is to electrons what reservoirs or dams are to rivers. They tend to slow down the flow of electrons, and this is very helpful in circuit analysis. Now let's look at the concept of resistors. Resistors, as we know, are simply devices which offer opposition to the flow of current in the circuit. It comes in various forms. We have the surface mount resistors, the variable resistors, the standard resistors, and many more. The interesting thing about them is that they are commonly found in almost any kind of electronic device. A good example is the potentiometer variable resistor, used as volume regulators in various circuit designs. Can also be used for bass treble volume regulations. Types of resistors. There are so many designs of resistors. Each of them is channeled towards one goal, which is to oppose the flow of current. They comes in various forms. We have the standard resistor, the potentiometers, the variable resistors, we have the light dependent resistors, we have the SMDs, the surface mount device, and many more. The standard unit of measurement of resistance is ohms, and it uses this symbol to represent its value. Now let's look into the means of identifying resistors. Resistors are represented in circuit using this symbol as the means of identifying the different types of resistors we have. Let's take a look at the face valued resistors. These resistors comes with color markings, which we refer to as the color codes. Now, this color code helps us to identify the real values of these particular resistors. They comes in different bands. We have the 4-banded color-coded resistors. We have the 5-banded color-coded resistor, depending on the number of colors it has there. Now, here is a few illustration of how this works. Okay, here is the table that will enable you understand further how to calculate the fixed valued resistors using their color codes. Now, I really don't want you to memorize this table or try to walk around with it everywhere you go. I'm gonna give you a shortcut of how to commit this particular table into memory. But before we give into that, I want you to understand how this table works. Here represents the colors. We have the black, the brown, the red, all the way down to gold, silver, and none.
And here we have the significant figures, and these significant figures ranging from 0 up to 9. So we have from black up to white has the significant figures from 0 to 9. Only gold and silver has no significant values. There is one thing you must understand. In every fixed valued resistors, you must be very careful as to identify the bands. What I mean by band is the color markings. If the resistors has 4 bands, it simply means that the first 2 colors are the digits. The third color is the multiplier. Always notice this gap here. The gap tells you where to begin and where to end. If the gap is in between here and here, you should always know that you should know this is the end and the rest from here to here is the beginning of your counting, and that is very important. So notice the gap is always available in practically every standard resistors. Now, the something is applicable to the 5-banded resistors. Always count the colors. Remember, you will have the best way to recognize the band is the number of colors. So if you count the colors and they are up to 5, it is called 5-banded resistors. If they are 6, we have this. You know they are 6-banded resistor. One funny thing that you must understand here is for the 5-banded color-coded fixed valued resistors, they the the gap here always separates one color from the rest of the colors, and that marks the beginning from here to the end that is coming from here. Always remember this gap. This gap tells you where the end is and from where to start your color marking. The same thing applies to the 6-banded, but one funny thing about the 6-banded, or one important thing about the 6-banded color-coded resistor is it has 2 extra colors at the end. So you must take note of that, as that is very important in finding their color code. Now, how does this connect to the table that we are making use of? Now, how it connects to the table? For the 4-banded color-coded resistors, the first 2 colors are represents the digits. So we simply call them the digits or the significant figures. The third color is the multiplier, and the last color is the tolerance. Now, the same thing applies to when we have 5-banded resistor. But for the 5-banded resistors, the first 3 colors goes to the digits or the significant figures. The fourth color shows the multiplier, and then the last color is the tolerance. Now, what does that mean? The same thing applies to the 6-banded resistor. For the 6-banded resistor, the first 3 colors goes to the digits or the significant figures. The fourth color goes to this is for the significant figures. The fourth color goes to the multiplier, whereas the fifth color goes to the tolerance, and then the 6th color goes to the temperature coefficient. The temperature coefficient. Now, what does this imply? Now, it simply implies that while you take the reading for your resistor, you must also take into considerations the number of colors that it has and its attribution to the digits as well as the values. So what does that mean? Now, when we look at the table here, the table has column for the significant figures. So if it has 2 significant figures, you just take this and this. If it makes use of 3 significant figures, just take the 3 of them. They are all the same thing. So what it means is you just take down the significant figures the way they are, put them down, put this down. Multiplier, you just multiply the 2 significant figures for the 4 if it is 4-banded with the multiplier, and then tolerance represent the range at which it is operational. So that the limit at which it is operational. Now that is for the 4-banded and the 5-banded color-coded resistor. For the 6-banded color-coded resistor, it has a column for the temperature coefficients, which represents the amount of temperature that it is permitted to have. That's the coefficient of temperature that is permitted to have. So as in order for it not to fry out. So it is important to take note of that for you to understand how this works. Now this is the fail rate. The fail rate is often not really necessary for finding the color code of a resistor. So let's get started and do some little exercise on this. So back to this resistor. What is the value of this resistor? When I pick up a resistor and it has 4 colors and I know that the first 2 colors here, how do I get that? So to figure this out, what I'm going to do is I'll ask myself, where is the gap? So here is the gap. So this gap tells me that this is the end and this is the beginning. Now from that, I'm starting from here. This is my first color. What is it? Red. This is my second color. What it is? Red. So what I'm going to do is, since for this is 4-banded, these 2 colors are the digits. So I will simply check out what red is on the table. So from the table, red is 2. So I'll simply put down there 2. And how many 2s are there? I have another first red and I'll have another red. So I have 2 here. So now the third color has the color of blue, I guess deep blue. And what was I told that this blue represents multiplier. So I will simply go to the column that has multiplier and look at for blue. So find blue here, we search, here is blue, and blue multiplier means times 1m. 1m is 1 million. So 1m, so I will simply put down there multiplied by 1. 22 multiplied by 1 is simply 22m. So this is 22m, and tolerance is just the limit. So obviously this is 22 mega ohms, and that is the value of this resistance. Now what is the tolerance? The tolerance is actually, let's check it out. This could be gold or silver. So what if I say it is gold? So if this is gold, let's assume that this color here is gold. If it is gold, I will simply look out for gold and go to the column that bears tolerance and look out for gold. Gold here is 5. And remember, the column that bears tolerance is in percentage. So since gold, I'm assuming here to be gold. So it simply implies that this is actually 22 mega ohm with a tolerance of plus or minus 5%. And this is the value of this resistance. It simply implies that this resistance bears can handle this resistor can handle resistance within the range of plus 5% of 22 mega ohm to minus 5% of 22 mega ohm. So within that range is the value. Within that range, any value of resistance can, the resistor can handle that particular resistance or thereabout. So that is it for this type of resistance. So I want you to feel free to pause the video and tell me what this guy is. Now figure out the gap. So looking at the gap here, so let's find the value of this resistor. To do this, we have blue color here. And what is blue? As a significant figure, we check the band first. It has 1 2 3 4 5 banded resistor. So the first color is blue. So we just go to the table, we have blue here, and that is 6. Another color there is white. So go to white. White is 9. And another color there is black. Remember, for the 5-banded resistor, the first 3 colors represent the digits. So the first one is the blue, and blue is 6. So I will put down the 6. White is 9. I'm putting the 9. What's the next color? Black. And black is words. Black is 0. So just put down the 0. And the next color is red. Red is the multiplier, and red color, goes for multiplied by times. Where is it? Red is, okay, times 100. So I'm simply going to multiply 690 multiply by 100, we simply add two zeros there, and boom, that's what we have. So this is it, and this is 69,000 ohm, and 1000 can be substituted with the value of k. K means kilo, which is 1000. So I can simply call this 69 kilo ohm resistor. Now, what's the tolerance? The tolerance is, let's say the tolerance this time around is silver. So just go down to silver here, and I have tolerance, and the tolerance is 10. 10 means 10%. So it's going to be plus or minus 10%. Now, what if the color on the tolerance is none? If it is nothing, we give it a tolerance of 20%. Okay, so if you have none at the end, it simply means that the tolerance color is 20%. That's what we put in there, and that is how to calculate the value of fixed valued resistor. So anytime it comes around you can actually pick up any resistor around you, fixed valued, and look at them and tell the value of such resistance. The same thing applies to the six banded. The same thing, you just pick up the three significant figures and multiply them, and that is the value of the resistor. Then these represent the tolerance and that temperature coefficient, and this is how to I believe this is very helpful. Before I leave you guys, I need to tell you the easiest way to commit these values into memory. Now, how do you commit this value of resistors? That's this table comprising of the fixed valued resistor code into memory without actually going about the table or without memorizing this, so that it won't skip your memory. Now I've devised a very better way to do that, and I'm going to show you right now. Okay guys, let's get started. Imagine if you are trying to tune color, like you're trying to increase the volume of something. Now, what is the first color that you are going to encounter first? Assuming that you are trying to tune a color from its darkest to the brightest. So which color will you first encounter? Of course, you are right, black. That is where the beginning starts. Now, as you proceed to go higher, you get to meet a new guy, brown, which is nothing much bigger than the black. And as we proceed from brown, we meet the guy that gave birth to him, which is red. So nothing serious outside brown, because it's a little bit red is a little bit brighter than brown, which is a little bit brighter than the black. Now, as we move from red, we get to see the brighter, which is the orange. And as we proceed out from orange, the color is becoming brighter, and we are meeting yellow. And yellow is very bright that the sun can even shine on it, and we give birth to green. Everything turns green, and the greenish tends to vanish, and we get a blue sky. And as the blue sky gets bluer and bluer and bluer, it becomes purple, and deep purple, that we have violet. And as the violet turns deeper, becomes brighter, we give birth to gray, and gray down to white, and that is the brightest. So from black to white. So if you really want to memorize this code, I want you to just see it as though you try to tune the color like a volume of something. You got to start from black, dark, to a little bit brighter than dark, which is brown, brown, red, red, orange, orange, yellow, yellow, green, green, blue, blue, to gray, gray to white. That is it. And you could attach your gold and the word your silver. Remember, these two has no significant figures, and you should know that. So from these, you can label them, you number them. You have your 0, you have your 1, you have your 2, you have your 3, you have your 4, you have your 5, you have your 6, you have your 7, you have your 8, and you have your 9. Seems amazing, right? So that is the glimpse of how you could get this color. And the same thing applies applicable if you want to know the multipliers. The multiplier is just the same. You just have here to be 1, and you just add this word 0, and you have that guy. That's multiply by 10, multiply by 1. If you have black, you multiply by 1. If you have brown, you multiply by 10. If you have red, you multiply by 100. If you have orange, you multiply by 1000, 1k. If you have yellow, you multiply it by 10k. If you have green, you multiply by 100k. If you have blue, you multiply by 1000, which is 1000 times 1000. You know what that is. You have 1 million. So 1m, and if you multiply by violet, you have 10m. If you're multiplying by gray, you have 100m. And if you're multiplying by white, you are having 1000m, which is 1 gig. And that is one of the shortcut of how you can commit this to memory. Remember, in electronics, you don't cram, you don't memorize stuff. You simply commit them to memory. And whichever method that serves you best in trying to get those things done, that is okay. And that is one thing I love about electronics. Alright guys, this is gonna do for this video. I will see you guys in the next video where we're gonna look up to some laws governing some of the resistors behaviors and possibly try and build one or two circuits in order to demonstrate how resistors work. Stay connected, and more importantly, don't stop here. Try and explore as many resistors as possible in order to get familiar with how to easily identify their color coding. And you can simply do that with your multimeter. I will recommend you can get the multimeter, you know, of your choice, and you can actually use this to test. So we will cover this in our subsequent videos, how you can use your multimeter to carry out this test and actually figure out what the value of resistors are, and we as many more secure as possible we are going to look at. Remember, don't forget to give me a thumb up if you like the video, and don't forget to subscribe, share with your friends, and let me know what you think about the video or what you want me to do next. Bye.